Hi everyone! In this third part of Vellum Hair tutorial, we are going to explore one of the things I most love in Houdini. We are going to use other system or other dynamic operators like particles and pyro to create and animate our Vellum hairs. You will see that you can apply the knowledge that you already have and use it with Vellum. Hope you enjoy this new tutorial and have fun with it. Okay, let's first place our geometry node. Let's place our hairs. Okay. Let's dive in. Let's put a grid now. Instead of a circle, we've been working with circles. And this is a polygon already. Let's change the size, the orientation. Let's change the size to something like 2 by 1. Something like that. Let's move up a little bit. Okay, and let's move back. Something like that. Let's place a hair gen. Okay. And we don't want guides, right? We want the length to be, let's go with 10. Let's put these on -5. So we know that we have this center. And maybe let's even lower these. Don't need that big. -2.5. Okay, something like that. So this will be our hairs. So let's place a null. Let's go with base splines. Okay, because after we do the first system, we are going to create another one. So first, I want to show you how you can use other systems to work with our splines, with our hairs, okay? So as I mentioned on the previous tutorials, let me decrease this to 50 so we can see a little bit better. As you may know, the splines are made with points, right? So right now each spline has 8 points, okay? Or 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 points. Okay. Because it has 8 segments. So it has 9 points. So if it has points, okay, if this geometry has points, we can do the same things that we normally do on PopNet inside our Vellum. So in our case, for example, inside a PopNet, you can use a pyro simulation or a volume, okay, to affect your particles. So you can do the same. That is the magic of Houdini. You can do the same inside Vellum Hairs, right? Because if you put air, like configure air, let's change this to use a different thickness. And let's place a Vellum. Oops, what did I do? Okay, sorry. A tab, Vellum solver. Where is it? And I think it says on the inside, if you double click, wire pop forces is into the force output. So it already says here that you can use any pop force inside this node, right? So anything that you normally do on the PopNet, you can do on the Vellum solver. So in our case, we are going to use a pyro simulation to affect our hairs, okay? And create this cool and fluid animation. So let's for now go up. Let's turn off our hairs and let's create our pyro simulation. So let's go really quickly. I'm going to not explain that much here because I already covered this on the intro to pyro simulation. Let's lower this down. Let's change to polygon, change the frequency. Let's put this down a little bit. Maybe -1. Because I want this to be below the floor, okay, because we know that our hairs are on top. Okay, let's place a null. Let's go up, let's create this smoke emitter, and select this node, go to our shelf tool, go to pyro, and below is smoke. It will create everything for us, right? So here we want to go to gas resize. Let's turn off the clamp to maximum, okay? And let's decrease this a little bit. The padding, in our case, to 0.1. Division size, let's leave it like it is. And let's change a little bit to pyro solver. Okay, we want this to go up. And our shape dissipation is all right. We want to lower down the disturbance, lower down a little bit the turbulence, and we want a lot of confinement because we want that vortex, right? You can even put here a boost vortex boost. Oops, not this one, sorry. Gas, how is it called? Confinement. Gas, let me try to look for it. Gas vortex confinement, it's not boost, okay? And link this to the velocity update. It will add more of those vortex, okay? That puffy trick. Let me add a light so we can see a little bit better. Let's put the viewport like this, go to lights, control, click on distant light, create on the same angle as you did on the viewport. Let's go to top view and now back to perspective. Space, Shift H to see everything. Now we can see a little bit better our volume, right? Let me organize this a little bit. So this will be our smoke, and let's go with smoke out. Oops. Let me pronounce this correctly. Okay. Let me turn off this. We have our cool smoke. Let me cache this a little bit. So pretty cool. You can see that we have a lot of turbulence, so let me lower down this turbulence to 0.5 and this turbulence to 1. Okay. On our smoke, let's go here, let's delete this one. And here we can leave the density, we need the velocity because we are going to add vector particles, and the other things we don't need. Okay, so here, let's turn off this. Okay. And in case that you are low on RAM or computer, so let's just cache this, cache smoke to be faster while recording the tutorial. So let me cache this. Let me just check the animation before we cache if everything is all right. Okay, pretty cool. I think I can decrease a little bit this noise here. Let me press L. Oops. What is here? Press L, and here on add noise, I want to lower down the element size. So the start we will have more noise here on the start. Okay, so I think everything is all right, and let's cache this really quickly. Okay, be right back while this cache. So I have everything cached. Let's go here, let's load from disk, and let's place a null, keep things organized, and let's go out smoke. Okay, pretty cool. Let's just check our simulation. A simple pyro simulation, right? Nothing too fancy. So now, as I was saying, you can do advect points inside our Vellum, like you do on PopNet. So let's, I will leave this on so we can check that. So here, let's go and increase our AirGen segments. Let's go with 20 for now, just to keep things light while recording. Okay, 50 on density, that's fine for now. And as I was saying, inside our Vellum solver, you can wire pop nodes inside this Vellum. So as you do on the PopNet, you can do pop advect by volumes. Simple as that. So now you come here and say, look, go get our volume. Let's go to smoke out. Okay, use this volume. Update the velocity. This is up to you. I like to use the velocity. Some guys like to use the position or the force. I like to use the velocity, and advection method, I like to use trace. Okay, adds a little bit more process between voxels. Okay, and now if I press play, you will see that this volume is affecting our particles, and our particles are controlling our hairs, right? Right now we can see that our hairs are falling down. I don't really want that. So here on our Vellum solver, let's go and turn off our gravity. Okay, let's go here. And let's add some color, because right now everything is white and I don't really like that. So let's go to our previous. Let's see where is it? Let's go get our color hairs. Okay, the same that we did on the first part, on the first tutorial. So now let's go to our tutorial. Let's place here. Okay, so now we colored our hairs so we can see a little bit better what we are doing. And let's change the background to dark and turn off our grid. Okay, more clean. So let's see how it behaves. And now nothing happens because I don't have the blue tag on the Vellum solver. Okay, it is processing until 150. Okay, cool. Now we see that our hairs are being advected by our points. Okay, pretty cool. So now let's turn off our smoke. You can always come here. As you can see, we have low segments. Okay, so let's increase this to 40. And let's see, it will take a little bit more time to process, but we have more smooth lines. Okay, pretty cool. And even if you think that you don't have smooth lines as you wish, because you can see here we have some hard edges, you can always do like we did on the other tutorials, put a resample. Okay, and here on treat polygon as subdivisions, it will keep the lines more smooth. You can even decrease the length. So you are adding more points, but it will be, you will have more smooth lines. Okay, pretty cool. Let's go here and check our animation. This is some cool fluid animations. And now you can come here to the air gen and look, I want this more dense. And let's see how this behaves. So now, as you can see, the process time, the simulation, it is taking a lot of more time than we like to, right? Because it is processing. Let me see how many primitives. Let me stop that. We have now 1000 primitives and it is taking a lot of time. But the result is even better. Okay, we have more dense hairs. Okay, this is cool. See how it looks. Pretty cool. One thing that I explained on the second part that we are not going to use on this one is that, remember, we did the air gen, right? We normally on the previous tutorials, we come here, combine these now. I want this to be really dense. Okay, we were using 5, right? 5 and 40. Okay, really high dense, and now use these as guides. And let me come here, attributes, and we need to pass the color. Right. So as I explained this on the previous tutorial, this is not going to work. Okay, it is only going to work on the hairs that are have the root fixed. Okay. Because on this type of simulation, we will see that some hairs, as you can see on the middle, these hairs are going up. Let me cache a little bit forward. So this little trick that you simulate with low density hairs and then use another air gen to have a density, add more density and use that simulation guides as guides for AirGen, this will not work on this because your hairs are going away from the base geometry, right? So as you can see, these hairs are no longer connected to these ones. Okay, so we will see that we lose some hairs, right? So in order to have this dense system with a lot of hairs, you can, if you have a really powerful computer, you can really come here and let's increase this to 5,000. You will see that this is going to take a while. I'm going to save it. And you will see I can't really push this, use this on my computer because it's going to take a lot of time to render these high numbers. Okay, as you can see, it is only on frame 4. It's going to take forever because we are working with a lot of numbers, with a lot of primitives. Okay, so let me check. Now we have 10,000 primitives. Okay, and that is too much. Let's go with 250. Okay, I think that my computer can handle that many. 500 primitives, and let's see the speed. Okay, the speed is cool, and I'm recording, so it's a little bit slower. So how do you turn this low density air simulation into a dense air? It's easy. It's just going to use the same trick that I did for the tutorial on the millions particles, right? Let me go and grab that tutorial really quickly. So let me just go to Doxia Studio, to my website. Give me just a little minute. Okay, so we are just going to do the same trick that we did this on the million particles tutorial. So we are going to use the wedge trick to simulate these multiple times and then combine everything, every file cache into a merge, right? So we will have a dense air. So we are going to run these multiple times until we get what we want. So let's go with no. Let's go with alt low air sim, right? And let's place a file cache. And let's go with pyro low air sim. And I forgot to say cache. As you know, I don't like this heap name. Okay, so let me switch the UI so we can have everything here. And I don't lose you. Spin this and split this window, and let's go to out. Okay, so let's use the wedge trick. Let's place a wedge. You have to be on the out, okay, on the outputs. On the wedge, we need to link that file cache, okay. So you come here and select the cache system. So you can come here to hairs, pyro low file cache, and grab that render. Okay, or if you want, you can double click and grab this node. Okay, so come here and grab this node here. Pretty simple. And now we need to tell our file cache to save the wedge information. Otherwise, it will overwrite the file caches. Okay. And we need to come to the wedge and say, look, cache these 5 times. I'm just going to do 5 times for this tutorial. And we need a parameter to change between file caches. Otherwise, if we don't have file cache, it will run this simulation over and over without any difference. So one thing that we can do is just come here and change this scatter seed. As you can see, let me go to the first one. As you can see here, if I change this seed, you can see that our splines are changing the initial position. That is enough for us. So let's right click, copy parameter, go to the wedge, press plus. Okay, let's go with seed air as a name. On the channel, right click, paste relative reference, and this is already waiting for a channel, so clean this up. And our range, just put some random numbers. Okay, let's go with 4. That really high numbers. Okay, so to recap everything, we are saying with the wedge, run this file cache 5 times, okay, and change this channel. This channel is this seed. So every time that it's going to run the simulation, it's going to have a different scatter. So we will have different hairs on every single simulation. So let's go to the wedge. Let me just verify that I have the wedge. It's really important. I keep always forgetting this. It's really important to have $wedge, okay? And go to the wedge node and press render wedges. Okay, now it's going to run this simulation 5 times and save everything on cache. So I'll be right back. Okay, so I cached the 5 file caches, okay, with wedge, and now let's go grab them. So let's go file cache, load from disk, and let's pick one by one. So now I have the 5 nodes, okay, and as you can see, they are different from each other. They have the same animation, but the starting point it's different. So everything combined, you will see that. Let's go place a merge. We have now a more dense system, right? Instead of having, let's go cache to 60. Let's go here. So before we had 500, right? And I only ran this wedge 5 times, okay? So as you can see here, we have this dense with 500 primitives. And now with the wedge, really quickly, under 3 minutes, we have now 2,400 primitives, okay? So we have 2,000 hairs here. So this is pretty cool. So now, as you can see, we have a more dense and more cool fluid animation. And we can scroll them out really quickly during. Okay, they are stopping here because we had the dissipation really high. So the smoke is dying here. So they don't have more velocity to be advected. Okay. So let's go back to our hairs. Let's keep going. So now I show you one way to use other systems to change your Vellum hairs, right? And now I want to show you how you can use other systems to create your hairs, then use those hairs into this simulation. Okay, so let's go. Maybe I'm going to duplicate this one. So this will be the hairs pyro, okay, and these will be hairs from particles. Oops. Okay, let's turn this off and let's delete this because we are going to do another system. So let's go back. Let's delete this, and now, as you can see, we are using the same basic guides like we did on the previous tutorials, but now I want to show you how to use other systems like PopNet to create your hairs, right? So let's place a circle and let's do something about that. Let's leave this just on the side. Let's go to our circle. Okay, let's place this on the floor. Now I want a NURBS curve. Okay, I want only the spline. And let's place a scatter. So we have scatter points here. Let's dial this down to 250. Let's increase our size to 2. Okay, pretty cool. And let's add colors to these points so we can see a little bit better what we are doing. And because now we are working with points, we need to go here to these color hairs. and change these primitives to points. Okay, otherwise it won't work, because now we are working with points, we don't have primitives. And as I mentioned, we are going to use the popnet. So we have our particles. Let's go to our pop source. I'm going to do this a little bit quicker because I covered these on my first tutorials 2 years ago with the intro to popnet. So what we are going to do is just emission type all points to use these scatter points, right? And we want to emit only on the first frame. So let's go $ff equals to 1. So emit only on the first frame, okay, on frame number 1. And right now it is not doing anything because we are just emitting particles and not adding any velocity. So let's go and use some math. Okay, I'm going to use the same math that I explore creating a custom velocity on other tutorial. So as you can see, you can apply knowledge that I explained for like creating custom velocities, custom volumes on Intro to Pyro Part 2. Now we are going to use that on the PopVop. Okay, pretty cool, using the same knowledge that we already know. So let's create an attraction force, right, with subtract. So let's place a constant. So this is going to be our attract point. Oops, point. And this is going to be a vector. Okay, cool. So let's make our custom velocity. Okay, so right now we are calculating the direction of these points towards our attract point. Okay, you can change this. For example, if you put 2, our points will now attract to 0 to 0. But we want to attract to the origin. Okay, so let's go with that. And let's place a parameter. It's just going to be a float. Let's go with attract force. Okay, and let's multiply this new vector, okay, for our attraction and link this to the velocity. Let's go up, and here if I go here, attract force, let's place 1, and if I press play, you will see that our particles will go to the middle. See? So we created just our attraction force. Very cool. Let's move this up, and now let's create our vortex force like we did on the Intro to Pyro Part 2. So for that, we are going to use this attraction vector that we created here, right? And we are going to use that vector pointing to the origin, and we are going to use simple math to rotate these 90 degrees. One way to do that is going to Google and try to look for a really simple, like we did, search, right? When you don't remember math, you can always use Google and just search for math vector rotate 90 degrees. And we need a vector 2D, okay? It's easy to work with 2D because we are not using really 3D here, right? We are just working with 2D. Okay, we have everything on the floor. So in our case, you can see to rotate a vector 90 degrees clockwise, you just switch. So the x is now the y, okay, and the x we need to multiply -1. In our case, instead of using y, right, we are using z because we have things on the floor. So let's do that. Let's convert vector to float. Where is it? Vector to float. And link the subtract vector. Okay. Now we have our floats, and let's convert this float to vector. And we know our y will be the same. As we saw, we need to switch. So instead of y is z, so let's switch this. So our z will be our x, and our x will be our z, but we need to multiply this by -1, right? So let's go with multiply constant. Okay, and here let's go with -1. 1. So now we have this vector towards the origin, rotated 90 degrees on the floor, right? So now let's go with parameter. Let's call it vortex force. Okay, let's multiply. I forgot to mention, this is really important that you link first on the input 1 the vector, and then on the input 2 the float. Okay, otherwise, if you link the float first, this multiply won't work. Okay, because we are telling, okay, multiply this float for every single value on the vector. Okay, so now we have both the attraction and the vortex. Now let's combine them with the add, and let's see what happens now. So now we don't have vortex, okay, so it will go to the middle as we did before. Now if we add a little bit of vortex, you will see that they will rotate. Let's turn on this. Okay, you can see that they are rotating. So with these parameters, you can control the force. Let's go increase the vortex. As you can see, they are rotating. Pretty cool. And now let's go. Let's go and create a trail. Okay. And here, let's put the same number as we have on our timeline. Let's go with frame end, so it will pick the 300. Let's go here, and now we have points. Pretty cool. And we can come here and connect as polygons, close rows, and we have our trails. Pretty cool and simple. I think this is a really cool animation. It's just simple vortex. Now it's too linear for my taste. You don't need to add this, but I like to add a little bit of turbulence. So let's add turbulence. Let's link the position to our position. Let's come here, 3D noise. Let's add another parameter for our turbulence force. Let's go with turbulence, or let's go with noise force. And at this moment, I want to be a vector, okay, to control the force for every single coordination. And again, multiply to control the force of this, okay. And let's add this multiply to our add. So right now, our final velocity will be the attraction force, the vortex force, and then our turbulence or noise force, okay, everything combined. And I want to promote these create input parameters. Cool. So now we can control here. Let's change this to spark convolution. And I want one here. I don't want a force on the Y because I want the points to stay on the floor. And let's go something like that. And let's see what we got now. Pretty cool. We have some little bit of noise, as you can see. We can even come here and let's go increase the frequency. Let's see how it behaves. Okay, you can see we have really cool. So now we have more organic and not so linear movement. And we can come here and maybe let's decrease this a little bit and let's go with 1 and everything is fine. I think it's cool. We increase a little bit the attraction force to go to the middle quicker. And maybe let's normalize this one. The attraction. Let's go normalize. And let's normalize this and this. Okay. I think that is better. Let's see how it looks. It goes to the middle a little bit faster. Okay. Cool. So now we can link that to our Vellum, right? Because now we have primitives. Let's go here. And you can see that we have 250 primitives because we have 250 scatter to start with. And we have almost 30,000 points. That is way too much. Let's try and decrease that a little bit with the resample. And let's see how it looks now. 20,000. And we decrease almost 10,000. Let's go with subdivision and let's increase this. 3 is way too much, as you can see here. Let's go a little bit like that, or maybe 150. And let's see how it looks. Okay, we lowered the points way too high. That is important because if you have really high density of points, the Vellum solver will take a little bit more time to process. But let's go with that. So now we have our points. Cool. And let's first time shift. And let's stop this at frame. Let's see when we got to the middle. 60. 60 is cool. So Control Shift click to clean that expression and go to 60. So now if I change my timeline, it will always stop there. So now let's go here and everything will work for us. So let's go. Oops. Now it's processing. So I hope this will work. Let's see. So now I've used PopNet to create my splines with particles. Cool. And then I stopped the particles to have the points in place, and then use those hairs to be transform those primitives into hairs, and then use Vellum solver. So as you can see, they are behaving like I want. There's something wrong. What happened here? So let me see the error. What happened? So everything is correctly here, but then the Vellum solver is saying that we got some errors. Invalid source. So let's see what's going on. So they are not enjoying these primitives. So let's try another way. So instead of converting them to trails here, right, to polygons, let's preserve original. So we have points, right, and those points will have a common ID attribute. Okay, so each point on the trail will have the same ID as the origin point, right? So we can come here. Let's go with add. Maybe this way it will work. Let's go by group and use by attribute, and let's use the ID. Okay, so now we have points again. We have primitives, way less primitives than we had before. That is cool. So maybe we don't need to resample now. Now let's go with time shift. Let's see how many points. 15,250 primitives. And right now I think we will still have one error. Let's go here and let's try and clean this. Because now we have duplicate point ID attributes. So our primitives, the points on the primitives can't have the same attribute, okay? So one way to clean that, just go to attribute delete. And they are saying that we have the point ID. So let's go to point and delete our ID. Okay. Now it is working, and you will see that our pyro simulation will now advect our new splines, our new hairs. As you can see, it is starting to change. Okay, pretty cool. Now, again, this is the low density, right? Let's press L to clean everything out. Let's clean these nodes that we are not using. So now we are using PopNet, right, to create our hairs, and then using those new hairs to create our advection hair simulation. Pretty cool. And this is the low density system, right? So what we need can do that we already explored is just have a file cache. Again, let's call it particles hairs effect cache. Okay, I like to have pretty extended names. Okay, and then use again another wedge. Link that here. So let's select this, drag. Okay, and we want now just simulate 4 times to be quicker, and we need to change the scatter seed. Okay, so this time if we change this seed, where is it? Let's turn off relax. If we change this seed, you can see that our points will change, and if our points change, our hairs will change. Okay, so we just, oops, let's go with 250, wrong parameter. So we just need to animate this. So let's go copy parameter, go to edge, and here let's go with seed particles. On channel base relative, let's clean this and just give a random name, numbers, okay, for a range. So now we are saying again, run this file cache 4 times and change that parameter on the scatter, the seed. Okay, that looks pretty much it. Again, I was forgetting to add the dollar wedge, really important. And I know we will have one problem here, because I had, when I was creating my first the study for this tutorial, is that this trail, okay, so to explain to you, our popnet is using cache, right, and then our trail is using another cache. But to wedge, when it is creating file caches, it will only clean out the cache from the DOP networks, from the popnet and then from the Vellum solver, right? It won't clean the cache from the trails. So even if you change the scatter and the DOP network, the popnet will create different particle simulation, our trail will always use the same cache system. So we will recreate this trail. Okay, this trail node, I will leave this on the side. We will create this trail node using another popnet. So as you can see, this trail is just creating particles behind. Okay, so we will create this with another popnet. So let's place a popnet, and this will just be really simple. Let's go with popnet trails. And here we just need to tell, look, go and emission type, use all the points, okay? And don't use anything else. Don't add velocity and don't use anything. So here, let's set initial velocity. Let's clean our variancy, okay? So don't add any velocity for these created particles, and don't add ID attributes, because we need to use that ID attributes to create our polygons, right? So let's see. Now we have our trails, and if I check our add, now we have our splines. Cool. So now before we go to the wedge, I was forgetting one thing. You may want to have these particles like I have on my promotion video. You have these particles being created, okay, these trails being formed, okay, we are creating these trails, and then only after they hit frame 60, they will start the Vellum solver, right? So one way to do that is just using a switch, okay? So what we want is to have this like this. So the switch will be with the particles on the first frames. On frame 60, let's go on frame 59, we are adding a keyframe here, and on frame 60 we are going to use the second input, and our second input will be the final simulation. Okay, so let's go wait a little bit till this process everything. Okay, so until frame 60 use the particles animation, and then on frame 60 use the vector. But as you can see, our Vellum solver is starting right. It is starting on the frame 1, and that is not cool, because when we use the switch, we already have the particles a little bit ahead in time. So what we can do, let's link this here to keep everything organized. So, oops, wrong one. This will be here. Okay. So what we need to do is just add a time shift here, and we are going to do a little animation, a little expression that is going to -60. Okay, so now it will behave like we want. Okay, because as you can see with that little time shift, we can see that on frame 61, we are using the frame 1 from our Vellum Hair. And I can see that I did something wrong here. Okay, so the keyframes we need to change here. Here, go to 1, and on 60, stay on 0. Okay, and we can clean this one. Sorry about that. So on frame 60, keyframe 0, and then on 61, change to 1, and then this time shift will now work. As you can see, we have our particles forming our hairs, and then boom, they will be advected. Cool, very simple. And now we have all the animation, and I think that I want to resample after that, after the animation. Okay, this will keep things more fluid and better. Okay, so the resample is after the switch. And now, oops, I have a few file caches wrongly here. I don't know why they are here. So now I have everything prepared for our wedge cache trick. To have a little bit more dense. So we already, I already said that this trail won't work with our wedge. Okay, and now we are changing this global seed, and I think everything is correctly. Okay, then we have the time shift, attribute delete, and I think everything is all right. Do I need to clean? Let me check just. We could clean these to be faster on the Vellum, because we are processing points with a lot of data that we don't need. So let's change this to delete non-selected and just keep the color and the position. Okay, so this way our points will just have colors and position and nothing else. And then our time shift. So now everything will work. Cool. So now let's go here. Let's be sure that our cache, let's reset our cache. Reset simulation. Clean everything else. Okay, and our wedge, let's check if everything is all right. So we have our file cache linked to the wedge. We have the seed particles that we need to change, and I want to run these 4 times. Okay, and cache everything else. And I'm going to cache just 210 frames to be faster for this tutorial, and be right back. Okay, so I have the wedge done. So let's grab the file caches. Same process, let's load from disk, and let's grab those 4. Okay, and let's link them to a merge. First, let's be sure that we got everything different. Okay, cool. So our seeds change, and because we didn't use trails, our pop nets and our Vellum, the right way to call them is our DOP. nodes, our simulations, our dynamic operators are being resetted, cache are being resetted with the wedge. And now on our merge, you can see, for instance, that we have a different and more dense simulation. This is pretty cool. Okay, so this is one way. Let's put a null. And let me think, sorry. Out hairs, okay. And everything is correctly to render. So on this one, we don't need to promote parameters because the color is already on point attributes. To render this on our hairs pyro, right? On this one, I think we need to promote because our color are on primitive. So in order for this to render with redshift, remember, we need to promote, or in other words, change the color attribute from primitive to point. Okay, so we can use that on our redshift. Let's go out hairs. Okay, that is pretty much it. Now you know how to use another system like pyro to move your hairs. Cool. And you know how to use other systems like particles to generate your hairs. So as you can see, Houdini, this is the beauty of Houdini. You can just link everything that you want and create whatever you want and apply the same knowledge. On this tutorial, we apply knowledge that we already cover into PopNet. On my first tutorials 2 years ago, we applied knowledge that we learned on Intro to Pyro Effects tutorials. And now we are applying the same knowledge on Vellum. That is pretty cool, and that is the thing that I most love in Houdini. So before we close this tutorial, I just want to show you the other animation that I did. Okay, this one, let's go back. Let's go to camera 1. So this animation, this is going to take a little bit because I have a really dense hair, right? So this one, to show you what I got, so I have this animation. They are starting with a grid, simple as that, okay? And then the only difference is that on our tutorial, I had the pyro simulation going up, right? Let me go here. So we have this pyro simulation going up, affecting our particles. On this simulation, I had the pyro simulation going to the floor. Let me turn off and colliding with the ground. That is just what I had. So I have this pyro simulation. Okay, simple. On this one, let me go to frame 1. On this one, I didn't have any confinement. So this is processing. Let it think a little bit. On our pyro solver, on the buoyancy, I have one on X to go to the right and minus 1.5 to go to the floor. So that way I have this pyro simulation like this and colliding with the ground floor. Okay, so this is the only difference, but again, I'm applying the knowledge that we already covered in this tutorial. So I hope you enjoyed these ones, these 3 tutorials about Vellum Hair, to explain you how to create really dense hair and cool abstract fluid animations with hair. Really simple to follow along and easy to learn. So now it's up to you to explore new ways. And don't forget to show me what you have created. And I hope you enjoyed this one. Please leave me some feedback on the comments. I really want to start communicate a little bit more with you to know what you think about the tutorials and what you would love to see next. So I hope you enjoyed this series about Vellum Hairs and see you on the next one. Bye bye.